So what we can see from last year's code is that we had all sorts of files mixed together. Some were autonomous mode commands, some were objects for our sensors, but everything was sort of in the same package, not necessarily organized into command subpackages or into subsystems. The drives and pretty much all of the objects used throughout all systems were declared in robot.java. Again, against the recommendations that we're going to take a look at, that says that these should be declared in subsystems. We really want to get all of these components in their own subsystems, and that means within the file structure of our code base, to get them within all of the properties, so the motors and the functions. So we'll have them declared here, and then the commands to do certain actions built as separate files or classes within that subsystem. Have a subsystem like a ball shooter, then that's where we declare the motors, we set the properties, and we create a constructor that when the robot is initialized, instead of putting all of the code in robot.init, instead in the creation of this shooter subsystem, that's when we instantiate our motor controls. So set specific methods like set shooter, which would allow us to configure speeds for both motors. So that way we take a complex system and add in a simplified method that would allow us to control multiple elements that comprise the subsystem. The relationship between command objects and the command base object, I'm still getting my head around. So it looks like that the command base is sort of head of operations, like the panel that you'd get on your drive controller. So the computer that's running the driver station. And then because it requires this thing, if this is on, all of those things are subordinate to the panel control. So it takes control of those objects, so they won't run without this thing's. I don't know. So we need to start setting this up and experiment with this to get some practical experience around these concepts, so we can better contextualize them. To that end, let's go and start creating a project. And so they're recommending that we, when creating a project, start with a command-based robot. That'll help us organize our code. Eventually, we can focus specifically on an iterative robot if we decide to move away from the command-based robot. But I think this is an interesting design pattern that we should follow until we can really get our heads around it and evaluate. If it's not right for us, that's fine, but let's make sure that we really understand its benefits and start with as much structure as we can. Worth setting up our new code base on top of our GitHub. Because the new software is going to be released once the competition comes out, we might want to wait for that to start our official code base. Until then, I think we can just start Alera, which is the name of our robot this year, temporarily. So we can go start a new project, a new robot Java project. Team number is 5973. And we're going to do a command-based robot. There we go. We call this Alera Preseason. See now that the way that this code base is organized, we have our robot software package, but we also have separate modules for our commands and our subsystems. The example I set up in Slack, you can see that they have a separate drive subsystem, and that instantiates a lot of the motors and the encoders, Okay, this is actually declaring, not instantiating them. Because during the constructor, we can see that instead of instantiating them directly, they take some of these left drive and right drives as parameters and then set up the systems. So that means that elsewhere, perhaps in robot.java, they will instantiate these drivers. Specifically, here they are instantiating them. And that's where they tell you, okay, we have software that tells you about how this motor works. That's handed to us by WPI-lib, and it's plugged into this port, which is saved in this file. That way, there's just one consolidated file where all the numbers are kept, all the magic numbers. You know, what port this is plugged into and what port that is plugged into. So that's all being set up separately. And then a bunch of all of this setup subsystems is all being happened here. Is all happening in robot.java, this long mess stuff, when it seems like that's sort of against their own best practices, because shouldn't these configuration of the drivetrain happen within the drivetrain? So if you're setting this up, why don't we do it right here? This will try, and we can set up our drive here. See from what we had previously in our test code so far, we have a couple left and right motors already set up here. Instead of instantiating them in the declaration of instance variables, let's do that only when we're creating the drive instead. So now we can say motor L1 is equal to new Jaguar motor, and let's put it inside the L1 port. That way, if we reconfigure, it won't be hard-coded out here. These are magic numbers. That means like it's stuff that you have to remember or to change. And so the more that is kept in a convenient place, the easier it is to update if we were to change those. Whenever we create our drive system, we need to specify the ports being used for all four motors. And we should be more explicit with the security here. We'll assume that they'll all be private, so that means they can only be accessed within this class unless we were to pass them elsewhere. Let's assume that's what we'll need for now. But if we... did I misspell that? Whoops. Okay. And then if we need to make them protected, I don't know why we would do that. But if we need to make them public so that other classes can easily access them, we can do that. But I think we'll just make methods that allow public methods that say, hey, stop all motors, or whatever the case may be. More instance variables and instantiation up here, because all of these objects should be kept in this subsystem. But now, if we're starting to look at how the teleop periodic works and how it's making adjustments to the raw axis of your gamepad to avoid, some of that dead space and the beginning, so it doesn't drift when it's supposed to be just idle. And then we update the arcade drive. Well, instead of this being right here inside the periodic, similar to how our exemplar does it, they have their own arcade drive method here that takes in the throttle and turn power and all these other, and then factors the deadband, as well as a whole bunch of other logic that they can. And so trying to just get my head around exactly how they do it here, java.comment right here would be super helpful, just to help explain the rationale for this structure. But I think this is where we want to start going. It actually looks like once you set up this open loop, it'll continue to get the signal from the left and right motor speeds. This is something that we need to continue to investigate. Anyway, I don't want to keep on going too much longer. Why don't I stop here? This is sort of the direction that I think we need to start pivoting to. Let me know if you have any questions. I've got a dozen myself, so we still need to sort of feel this out. But we want to start organizing our code base into commands and subsystems, and this is going to help all sorts of ways. But we'll really see it as we start exploring this in greater detail.